Right, another thing that radian measure is useful for is when we're finding not so much the whole circumference, but just a length of the piece of the circumference, an arc, and so on. So we know, of course, the circumference of the circle is 2 pi r, and the area pi r squared. Okay, but if I just want a piece of the circle, so AB, so the arc, well in fact there's actually 2 arcs there. Right? We have the minor arc and the major arc, and we usually assume when they talk about the arc, we usually assume they're talking about the minor arc, unless they mention it otherwise. So it will make some angle at the centre. Yeah, the ratio of the angle at the centre is the same ratio of the whole circumference and the ratio of the area. So doing it in radians makes it a lot easier, because if you have a look at the ratio, the angle is theta, but the entire circle is 2 pi radians. So it comes up with a very nice formula now, because the 2 pi cancels with the 2 pi, and we just get a simple little formula: length is equal to the radius times the angle. But of course, remember, that angle has to be in radians in order for that formula to work. A similar thing happens with the area. So OAB, that would be a sector, but again, we've got 2 sectors there. We've got the minor sector and the major sector. And the ratio, theta on 2 pi, and that one cancels down, and we get a nice little formula, a half r squared theta. So if we look at an example of that, and we have 45 degrees at the centre, and I've deliberately used degrees here to highlight, hang on a sec, when I use this formula, I don't substitute in 45 degrees, got to be in radians. So the length of that arc would be 5 times pi on 4, so 5 pi on 4 would be the exact value. And the area, half r squared theta, and that works out to be 25 pi on 8. Another interesting question that they often ask is something like this: what about the minor segments? So rather than the sector, they just want the segments. So the segments is when we cut the circle into 2 parts by drawing in a chord. The minor one would be the small one, so the bit I've just hashed in there, that's what we want to find. The way I can do it is the area of the sector, and then just take away that triangle then. And we can use our half AB sine theta. Well, in this case, A and B is both the radius. So we get half of r squared sine theta, common factor of half r squared, and that leaves us with theta minus sine theta. But again, remember, theta's got to be in radians. Some people like to remember that as a formula. Fair enough. Whereas others just think, oh, well, I'll just construct it every time and think, oh, well, sector minus triangle. Whatever your preference is. So substitute in and look at that wonderful exact value. 25 pi root 2 minus 100 over 8 root 2 centimetres squared, of course. Okay, so 11i's got some questions on that.